Okay everyone, this is my third video and we're going to continue with some synthetic substitution, and in this video you're going to see why I pushed it so hard in my last video. Anyways, let's get started. On this one here, let me make this very clear. They want you to plug in or evaluate when A equals 4 in this case, right? That means you would plug in 4 in each of these A variables here, right? So if we were to do it old school or with our calculator, we would type it in exactly as I'm writing it. See how I'm using parentheses, and we plug in the 4. That's a 4 squared, a 19x minus 1, or 19a. But instead of doing all of that work, which is fine, especially if you're using a calculator, okay, why not use synthetic substitution? Watch again how efficient this is. I'm just going to take the coefficient. 1 for the A4, minus 9 for the A3, 15 for the A squared, 19 for the A, negative 1's my constant. Leave my gap there, my hockey stick. This time, no tricks. They're telling us the root is 4, basically. And so, here is synthetic substitution. Bring down the first number. I multiply those. I get 4. 4 minus 9 is negative 5. When I multiply those, I get negative 20. 15 minus 20 is negative 5. When I do that times the 4, I get negative 20 again. That leaves me right here with negative 1. Times with the 4 one more time is negative 4. My result is negative 5. Now what we just figured out, guys, is when we plugged in 4 for A, we got negative 5 out, right? And that's actually an ordered pair on this graph, on this function. And let me show that to you real quick. So I actually already have a graph that took a picture of it. Right here. Right here you can see that right there, oops, I have the wrong graph. Sorry about that. There we go. Notice my scale. If that's 10, this would be positive 2. This would be positive 4. And if I counted this way, negative 2, negative 4, you could see right there is negative 5. So positive 4 is negative 5 on the graph, right? Pause the video and study this. Make sure the scale in this case, guys, we're counting by 2's for each square. But 4 negative 5 is exactly what we got here. Okay, let's do another one. Again, I'm going to do the rest without any big explanations. I'm just going to take the 1, the 5, and the 12. Put my gap and hockey stick down. M is negative 1. So we're actually going to evaluate or plug in negative 1. So we bring down the 1. When we multiply those together, we get negative 1 here. 5 minus 1 is 4. When we multiply that, we get negative 4, which means positive 1 there. 5 minus 4 is 1. Times 1 final time right here, we get negative 1. 12 minus 1 is 11. What we just figured out is if I plug in negative 1 for the variable m, I get 11 as my result. That is the ordered pair of the graph of the function. Let me show that to you. So negative 1 is supposed to be 11. Here's the actual graph. Now notice, guys, the scale this time we're counting by 5s. So that would be a 15, that would be a 10, that would be a 5. There's my 0 right there. Here's my negative 5. So notice right in here, if I go to negative 1, somewhere out right there, right up there you see, around 10 or 11 is the point on the graph. And in our case, we know it's negative 1, 11. Okay, pause the video if you need to. But I want you to understand that when we do all this algebra, plugging in, we're finding points that are on the actual function graph. Okay? So, let's keep going here. Number 25 is the next one, right? We just did 24, did we not? Yes, we did. Okay. So on this one again, I'm going to take the 1, the 8, the 6, the negative 19. I know I'm plugging in my negative 2. Bring down the 1, multiply that. Negative 2 comes up here. 8 minus 2 is 6. Multiply those, I get negative 12. 6 minus 12 is negative 6. Multiply those, I get positive 12. Minus 19 is negative 7. What we just figured out is negative 2 is negative 7. Let's check it out on the graph. So right here, guys, is my negative 2. You come down here, you notice they cross basically about right there. And that point is negative 2, negative 7, just like we got when we did the evaluation. Okay, one more. On number 26, again, let's just take the 1 coefficient there, the 9 for the n squared, 18, and the minus 11. This time we're plugging in negative 6. We bring down the 1, we multiply, negative 6. 9 minus 6 is 3. We multiply those. Negative 18, we get a 0. We multiply that times 0, of course, is 0. Negative 11 and 0 is negative 11. So negative 6 gives me negative 11. And if we look at the graph one more time, negative 6 is right there. Down here, you could see right there is my point on the graph at negative 6, negative 11. And so, guys, hopefully you're practicing, you're getting better with synthetic substitution. That's basically the end of my video, but I do want to add one more thing if you want to keep watching. I just want to remind you that notice the shape of this function, guys. Doesn't this function make this wiggly, as I refer to, snake or S shape? All cube roots look like this, guys. If it was, so this would be a typical x cubed looking function. If it was a negative x cubed, it would just flip around and go the other way like this. Well, actually, that's x4. Let me try that again. So instead of snaking this way, it would snake the opposite way like this. Okay? Maybe there's a bigger hump in there. But that's what an x cube always looks like. You ought to recognize x cubed. We did do an x4, did we not? That's another x cube. See how it snakes through? This one is a more extreme x cube. Usually that looks more like an x4. Like this one right here is actually an x4. Okay? See how it has that W looking shape. So try to remember x4s always make like a curvy W kind of shape. Okay? If it was a negative x4, then it would open up and down like that. So it would be a curvy M shape. All right? But I just want to add that on there just for a little added instruction. But guys, this basically concludes my video review number 3. See you in class.